Assalamualaikum and greeting. Have you ever stopped to admire the incredible structure of beehive? This tiny creature, without any formal decoration, without blueprint or ruler, construct perfect, symmetrical, and high efficient home. But you ever wondering why? If you build a hexagon, why not circle, square, or triangle? What makes hexagon so special that nature itself prefer them? Mathematics is often in subject of the number and the formula confined to the classroom, but in reality, math is everywhere. In exists, it where plants grow, in spirit of galaxy, in the structure of our bones, and yes, it's even home of peace. In today's videos, we are going to explore one of nature's most brilliant mathematical design, the honeycomb. We answer the three big questions. First, what is the bee choose hexagon over the choose other shape? Second, what is make hexagon a most efficient shape? Third, how has human engineering learned from bees build stronger, better structure? By the end of discussion, you will see the bees are not just a hardworking insects, but they are naturally mathematicians. Their work follow advanced geometry, principle that scientifically took centuries to fully understand. So let's begin our journey into the fascinating world of honeycomb mathematics. Okay, now let's tackle the big question. Why hexagon? Why not another shape? Imagine you are bee. Your goal is to build hope that is strong enough to hold honey, space efficient, so you don't waste a room, economical, using the least amount of fat possible. If we choose a circle, the first problem they have to face is gap. Circles are not packed together perfectly. There would be empty space that would extra weight to seal. There would be efficiency. What about square? They fit together without gap, but the corner of the square are weak point. If you push on the square, the edges will be easily buckled. So what about triangle? Triangle are strong and fits together well. But here the problem, if we use the triangle, they have food needs more wax than if they use hexagon. Why? Because hexagon can hold more honey using less material. Now, how here amazing part, B instinctively build their hive using the possible shape hexagon. Mathematical call this honeycomb conjecture, which the officially proved in 1999 by the Thomas Health. He showed that out of the possible shape, hexagon requires a least amount of material while covering the most area. Okay, real life example. Imagine you are tile designer and you want to cover the large floor with least amount of material. You could use square tiles, but if you switch to hexagonal tiles, you will need a fewer tiles and use less material, making it more efficiency and cost effectively. This is exactly what we are
If you
doing.
examine any piece of honeycomb, you'll see that it's constructed from tightly packed hexagonal or six-sided cells. Of all the possible designs, why do honeybees choose this one? To understand, you need to think like a bee. Bees need a secure place for their entire colony to live. Similarly, there needs to be a place where their nectar can be stored and ripened suitably until it turns into honey. That means there's a need for some serious space efficiency. A good solution is to build little storage units or cells just big enough for a bee to fit into, which can also double as the containers in which nectar is stored, the bee's very own honey jars. The next thing is to decide what the little cells should be made out of. Bees don't have beaks or arms to pick up things, but they are capable of producing wax. The thing is, producing it is a lot of hard work. Bees have to consume 8 ounces of honey to produce just 1 ounce of wax, so they don't want to waste it. So they need a design that allows them to store the largest possible amount of honey using the least amount of wax. What shape does that? Imagining for a minute that all bees had to attend Architecture Academy and go to math class. Let's say they asked their geometry teacher, what shape would give us the most space to store our honey but require the least amount of wax? And the geometry teacher replied, the shape that you're seeking is the circle, leaving the bees to return to their trial construction site and begin building their honeycomb using circular cells. After a while, some of them might have noticed a problem with their design. Small gaps between the cells. We can't even fit in there. That's wasted space, they might have thought. So, ignoring the geometry lesson and taking matters into their own hands, the bees went back to the drawing board to rethink their beehive design. One suggested triangles. We can use triangles, look, they fit together perfectly. Another bee suggested squares. Finally, a third bee piped up and said, pentagons don't seem to work, but hexagons do. We want the one that will use the least amount of wax and be able to store the most amount of honey. Yes, I think that's the hexagon. Why? It looks more like the circle than the others. But how do we know for sure? To find out, the industrious insect architects calculated the areas of the triangle, the square, and the hexagon and found that the hexagon was, in fact, the shape that gave them the most storage space. They agreed on an ideal size and returned to work.
So far, we learned that hexagons are most efficient shape in terms of space and material, but efficiency alone is not enough. The structure also needs strong enough to hold honey, bee larvae, and withstand external forces like wind, rain, or predator. Now, here we are things get really interesting. The honeycomb is the one of strongest natural structure on the earth. But why? What make a honeycomb stronger than other possible design? First, it have a equal force distribution. Imagine the pressure on the earth, the surface will con- concentrate, concentrate on the edge of corner, making with the point of figure. If you do the same with hexagon, the forcefully evenly distributed across a side mean no one part that honeycomb will take too much stress. A great of visual this by looking at the art in architects. Have you wonder why ancient Roman structure like the Colosseum or aqueduct that fill with the art is because art naturally distribute weight evenly just like hexagon do. Next, interlock strength. There are no weak points. Another reason honeycomb are strong is that actually is cell supporting each other. Okay, if you take one hexagon, it might not seem as super strong, but when you connect hundred of them side by side, they form a new network of support. Things of like a crowd on concert. If the one person start to fall, there are people around them naturally help support them, preventing them from hitting the ground. This is exactly what happened in honeycomb structure. Next, a lightweight the yet of study. The one of the impressive thing of the honeycomb is they have a use very little material while maintaining incredible strength. If we build their hive using solid wall, it would be too heavy. More weight means more energy needed to hold it up. But because honeycomb are usually thin but a strong structure, they are get same strength with a fraction of the material. Then it is also resistant with external force. B just don't store honey, they work on the cycling to the hive constantly. Strong wind, rain, and even attack from predators can put massive pressure on the hive. Yet the honeycomb design hold up against all this threat. This way, honeycomb structure have inspired all some most durable human design that bring us to our next section. Now that we understand that why honeycomb are strong, let's talk about how humans have copied this natural design for our own engineering project. You might think, okay, we use hexagon, so what? But the truth is scientists and engineers have studied honeycomb structure for centuries, applied them to the modern technology, construction, and transportation. Let's look at real-world example. how honeycomb structure help make our work stronger, safer, and more efficient. In the aerospace industry, weight is everything. The heavier of the plane or spaceship, the more fuel is needed. This is why airplane wings are not made of solid material, they would be too heavy. Instead, engineering use honeycomb panel to make them light but extremely strong. This allows panel to handle the extreme pressure and turbulence in the air while remaining light enough to fly. Okay, even NASA using honeycomb structure in the satellite and space probes. Why? Because in space there are no room or waste weight. Extra every extra kilogram needs to more fuel and higher cost. Fun fact: the Apollo Lunar module, which landed on the moon in the 1969, was built with honeycomb aluminum panel to make it light and strong possible. Without this, the space would be too heavy to leave Earth orbit. Okay, next, we are Alan using hexagon to build a strong structure human to many skyscrapers using honeycomb framework to distribute weight evenly and prevent collapse. Bridges are usually use honeycomb support beams to stay strong under the heavy traffic and bad weather. Only great of example is Great Wall of China, while it wasn't built using hexagon shape, it follow the same structural principle. The weight of wall distribute evenly to keep it stand strong as thousands of years. This is why modern architects still use honeycomb pattern in the construction today, because it time tested, naturally proven method of engineer. Next, you might not realize it, but your smartphone, electric car, and even solar panel using honeycomb design too. As you can see, battery cells are using often arranged in honeycomb pattern because it maximizes energy storage while keeping device light and compact. Solar panel also designed with hexagon cell to capture more sunlight efficiently. Think about it, if solar panel were arranged in square, there would be a tiny gap that can reduce efficiency. By using hexagon, scientists are ensured to the panel absorb maximum amount of light. Okay, next, do you know that even our body use honeycomb-like structure? Human bone have honeycomb-like interior. This make them light but stronger, like just like beehive. Doctors use honeycomb design in prosthetic limbs to make them durable and comfortable. 3D print bones implant use honeycomb pattern to help them fuse better within body. This means the same method that help bee build hive also help doctors save life. How amazing is that? We have explored how we accidentally discover one of the greatest engineer secret all of the time. Their hexagonal hives are not just efficient and beautiful, they are blueprint for some of the greatest human invention. From a plane to architect, from a solar panel to medicine, the honeycomb structure have shaped the world we live in. So next time you see a beehive, remember even the smallest creature on the earth can teach us the biggest lesson in science, mathematics, and engineering. Thank you.